हेलो फ्रेंड्स, वेलकम टू आवर चैनल द वे टूवर्ड्स केमिस्ट्री। आज हम एक क्वेश्चन डिस्कस नॉन्स्ट इक्वेशन फॉर द ईएमएफ ऑफ ए गैल्वेनिक सेल। इसके आंसर शेयर कर रहे हैं। देखिए, नॉन्स्ट इक्वेशन द इक्वेशन which explain the dependence of electrode potential and EMF electromotive force on concentration and temperature of an electrode at non-standard condition is known as Nernst equation. The electrode potential of an electrochemical cell depend on the concentration of the electrolyte solution as well as on the temperature. Nernst gave the relationship between electrode potential and the concentration and temperature of an electrolytic solution through an equation called a Nernst equation. In study of electrochemical cell, the electrode potential of the electrolyte as well as electromotive force of the cell is determined under standard condition, that is electrolyte concentration of each half cell is 1 molar and temperature is 298 Kelvin. However, this value will not be hold good when concentration of electrolyte in two half cell are different from 1 molar and if temperature is also not 298 Kelvin. Derivation of Nernst equation. We know that del G is equal to minus NEF. Del G is not equal to minus NFE node at standard condition, concentration 1 molar, temperature 298 Kelvin. According to thermodynamics, minus del G equal to minus del G node minus RT ln Q. इसको सॉल्व करने के बाद हमको मिलेगा डेल जी इक्वल टू डेल जी नॉट प्लस 2.303 RT log Q. Where del G is change in Gibbs free energy, del G node is change in Gibbs free energy at standard condition. R is universal gas constant. T is absolute temperature. Q is reaction quotient product upon reactant concentration. And E node is standard electromotive force of the cell. So now we get, after solving, E cell equal to E node cell minus 2.303 RT upon NF log Q. This equation is known as Nernst equation. At room temperature 25 degrees centigrade, F is equal to 96,500 coulomb. R is 8.314 joule mole inverse Kelvin inverse. Putting this value, we can get E cell equal to E node cell minus 0.0591 upon N log Q, where N is number of mole. This is another form of Nernst equation and is helped to predict the effect of concentration of the electrode potential at 25 degrees centigrade or room temperature. Nernst equation for galvanic cell. A galvanic cell is a device in which the free energy of a physical or chemical process is converted into electrical energy, or this cell is convert chemical energy to electrical energy. Such a cell usually consists of two electrodes immersed in one or more suitable electrolytes. When the electrodes are connected externally as well as internally if required, a chemical reaction occurs in the cell involving oxidation at one electrode and a reduction at another electrode. The electrode at which oxidation occurs is called anode, and at cathode reduction takes place. For example, galvanic cell. मतलब example of galvanic cell is Daniel cell. Daniel cell देखते हैं क्या है. In this cell, two metal rod are connected through an ammeter externally. Two metal rod used are copper rod and Zn rod. Copper rod is dipping into CuSO for copper sulfate solution, and Zn rod is dipping into ZnSO for zinc sulfate solution. An inverted U-shaped glass tube filled in with KNO3 or NH4NO3 solution called salt bridge is connected to electrode tank and complete the circle. मतलब cell U-shaped glass tube salt bridge complete the circuit by connecting to electrode tank, electrolytic tank. Cell reaction. Two type of cell reaction occur in galvanic cell: oxidation reaction and reduction reaction. Oxidation reaction in galvanic cell, oxidation occur at anode. The half cell reaction is Zn convert into Zn2 plus after losing two electron. Electron potential of Zn electrode at anode is, or electron potential of galvanic cell at anode is, E Zn2 plus Zn equal to E naught Zn2 plus Zn minus RT upon 2F. 2 is number of electron ln 1 upon Zn2 plus concentration. Here n is number of electron involved in the system. N is not number of mole. Sorry, this n is number of electron. इसको करेक्ट कर लेना. देखते हैं रिडक्शन रिएक्शन इन galvanic cell. रिडक्शन occur at cathode. The reaction is Cu2 plus convert into Cu after receiving two electron. Electrode potential at cathode is this. The overall cell reaction is this. So now E cell equal to E cathode minus E anode. So after solving this equation, we can get E cell equal to E naught cell minus 0.0591 upon 2 log Zn2 plus concentration upon Cu2 plus. This expression of Nernst equation, this is the expression of Nernst equation for galvanic cell. Thank you.